we'll change the columns. No, we'll change the rows into columns, and we'll check if they match.
Okay, so if it will match, that is 1, -1, 5, -1, 2, 1, and here we'll be having 5, 1, 3, right?
Yes,
Yeah, and it is symmetric, right?
it is.
Yeah, just a moment. Yeah, question number 24. How to do this question? If A and B are symmetric matrices, A is symmetric, okay, and B is also symmetric, okay, having same order, then show that AB is symmetric. We are supposed to show that AB is symmetric if and only if A and B commute. That means this. Let's discuss it. So if here it is written that A and B are symmetric. So if A is symmetric matrix, A is symmetric, can we write A transpose and A both will be equal, right? Kiran?
Yes.
And if B is symmetric matrix, we can write B transpose must be same as B, right?
Yeah.
And we want to check whether AB, okay, AB is symmetric or not. That means the product AB. How to check any matrix is symmetric or not? Suppose you are naming it P, okay, AB, whatever is the resultant of AB, we don't have matrix, but let's assume that whatever AB we are having, the resultant, that we are naming as a P. So basically, if we can see that P transpose and P are same, then we can say that, yeah, this is also symmetric. Yes or no?
Yeah.
Okay. So we want to check the transpose of AB. Okay. If we will take the transpose of AB, we want to check, okay, to show over here that if we will take the transpose of this, is it same as just AB? If it is so, then we are done with the proof, right?
Yes.
Okay, let's see how to do so. So suppose you have also learned the properties of transpose, right? If we are having a transpose and again we will do transpose, we will end up getting it. Do you know that, Kiran?
Yeah.
Okay, if we are having A plus B transpose, that is same as A transpose plus B transpose, right?
Yes.
Okay, similarly for A minus B, and if we are having AB transpose, that is same as B transpose times A transpose, right?
Yes.
Okay, similarly if we are having ABC transpose, it is same as C transpose, then B transpose, then A transpose. You must have learned the second last rule, but same is applicable for 3 matrices also. Getting it?
Yeah.
Yeah.
Yes.
So if you understand all these rules, then let's use these rules. Okay, we want to check AB transpose. We want to check AB transpose is what? Okay, we have one relation over here, we have another relation over here in hand, since it was written in the question that A is symmetric and B is symmetric. So if we will use the property number 3, we can say according to the property, this will be B transpose into A transpose, right?
Yeah.
Okay, that means B transpose is just B. A transpose is just A from relation from equation 1 and 2, right?
Yeah.
Now we want to prove that AB transpose is same as AB. But so far we are having in hand BA. Okay, and we cannot say that BA and AB are same. It's not algebra. Okay, in algebra xy and yx is same, but here while doing matrix multiplication we have to be careful. A into b and b into a will not be same always. Okay, so we cannot say this is same as b, ab. Okay, so here it is written that AB matrix is symmetric if and only if A and AB and BA are same. So yeah, we can say if AB and BA are same, then only we will be able to prove it symmetric, right?
Yeah.
Got it?
Yes.
Okay. So I'm summarizing. It was given over here that A and B are symmetric matrix. Usually you will be getting word problem, but who knows if you will be getting this type of question, okay, based on the property of transpose, using the properties and all. So you need to do it like this. You are having A matrix, B matrix, both are symmetric. You can write the condition that A transpose is same as A, B transpose is same as B. Now AB is symmetric, we need to prove. That means in our mind it must be clear that AB symmetric means AB transpose is equals to AB. That is the purpose to prove. Now here it is written that A and B, we are just using the property first. Okay, AB transpose we are finding and we are using the property. Then we are using equation 1 and 2. Now we are stuck, but then we will read the statement again given in the question, and it says that AB and BA, if these two are equal, then only it will be symmetric. Is it true? So yeah, we can also see that. Okay.
Yeah.
Any confusion over here, Kiran?
No.
Okay. This question, for what value of x, number 5, for what value of x is the matrix? We are having a given matrix. It's a skew symmetric matrix. Okay, for what value of x this matrix is skew symmetric? What to do over here, Kiran?
Mm. So we take the rows and we take the transpose of this first, and then we change the signs as well.
Okay, so A transpose will be this 0, 1, negative 2, negative 1, 0, 3, then x, negative 3, 0. This is A transpose, right?
Yes.
Then we will say that is A transpose must be equals to what? Minus A,
Anytime.
right?
Could
Negative,
you repeat that?
negative A, we can say A transpose must be equal to negative minus A, right?
Oh, yes. Yes.
Yeah, since it is a skew symmetric. So minus A, the matrix A is already given to us 0, 1, negative 2. Okay, negative 1, 0, 3. Then x, negative 3, 0. Then this minus we will take inside. So it will be still 0, negative 1, just 2. Okay, this is 0. This is 1, 0, and negative 3. This is, here we are having negative x, just 3 and 0. Now we will use the, okay, we can just compare this side and this side, right? By using the equality of matrix concept, element by element, we can compare. We are just supposed to find the value of x. So we can say x over here will be equals to 2, right?
Yeah.
Yeah. Or maybe we can see clearly this minus 2 and minus x are same. So basically we are getting the same, x is 2, right?
Right.
How we got it? Since it was written over here that it is skew symmetric, so we have used the condition of skew symmetric that A transpose must be equals to negative A, right?
Yeah.
Yeah. Now let me check, is there any other question which I really want to discuss? Otherwise we will be moving. Yeah, this one. This question number, let me check the number. Question number 2. Let me drag it first. Yeah. We'll also do A and B are symmetric matrix. Prove that, yeah. Number 1 also we'll do, Kiran. If A and B are symmetric matrices, okay, just like the previous question. I mean, not the last one. Before that, one question we did know. If A and B are symmetric matrices, so if A is symmetric, we can say A transpose must be same as A, right? Yeah.
Yeah, yeah.
And B transpose we can say must be equals to B, right? So here we are supposed that AB minus BA is skew symmetric. Now we'll be using the same logic. Okay, AB minus BA. We are supposed to prove that it is a skew symmetric. So in our mind, one thing must be clear. If you are naming it a matrix P, so basically we want to show that P transpose is same as negative P, right?
Yes.
Yeah. Do you want to say anything?
No, no.
Okay, let's continue. So basically we want to show that P transpose must be same as negative P. That means AB minus BA is skew symmetry. Now by using, of course, equation 1 and equation 2. So AB minus BA we are having, AB minus BA we are having. If we will, suppose we are doing the transpose over here. So in matrix, the rule is if subtraction is there and two terms are there, we'll be taking the first term transpose minus the second term transpose, right?
Yes.
Yeah, let's continue. So AB minus BA, we are supposed to prove it is skew symmetric. So basically we need to take the transpose, right? Kiran?
Yes.
Okay, so AB transpose in matrix, like something minus something transposes, you can take the first term transpose minus the second term transpose, right?
Yeah.
Okay, now this again you have learned a rule, that is if product is there and then transpose is there, we can write it as a B transpose times A transpose, right?
Yes.
Okay, let's stick to this part at first. So B transpose is B, right?
Yes.
Okay, and A transpose is A by using equation 1 and 2. Similarly, we will deal
Yeah.
with the other part. So BA transpose is there. We can write it as a this one. A transpose times B transpose, right, Kiran? Subtraction.
Yeah.
Now A transpose is just A and B transpose is just B, right?
Yes.
Okay, so we have got BA minus AB. Okay, if we will take out minus common from here, can we write it as a AB minus BA? Do you know that? Yes or no?
Yes.
Yes. Uh, like you are understanding, or shall I give more examples?
No, it's okay.
Got it?
Yes.
Okay. So we can say clearly we started with finding AB minus BA transpose. and we ended up getting negative of AB minus BA. So P transpose, if you are naming AB minus BA as a P, so P transpose we were finding, and we ended up getting minus P. So we can say, yeah, it is a skew symmetric matrix, right?
Yes.
Clear?
Yeah.
Let's do the next one. Show that this B transpose AB, okay, show that B transpose AB is symmetric. We have to show that it is symmetric. You can name it if you get confused with this. Okay, so many terms, so many matrices we can see over here multiplied, so you can name it P or maybe Q. Okay, we have to show it is symmetric. Okay, suppose we are calling it P, so basically we have to show P is symmetric or skew symmetric according as A is symmetric or skew symmetric. Okay, so that means we have to show over here, if A is symmetric, then this P is symmetric. If A is skew symmetric, then this P is skew symmetric. Is it making sense?
Yes.
Okay, let's do it. So again we'll be taking this P, okay, P transpose, and we will check, is it P or it is minus P. Accordingly we will give the conclusion that yeah, it is symmetric, or maybe no, it is not symmetric, it is skew symmetric. So let's do it. We will be taking P, that means this B transpose A B. Okay, that's transpose. Now only you have learned the rule, and it was known to you already that the property of transpose, that if we are having A into B transpose, that can be written as B transpose times A transpose. If we are having A B C transpose, it can be written as the last one, that's transpose. Okay, then A transpose, then B, which is already having the transpose, we also write it by using das, so that's transpose again transpose. Getting it, Kiran?
Yes.
Okay, now we know. Okay, do we know here? Let me check. So that no, here A and B symmetric is Q symmetric, nothing is given beforehand. So we will be writing it as it is B transpose. Okay, A transpose will be as it is, and this the last one, the bracket one, B transpose again transpose we are having, it will be just B, right?
Yes.
Okay, now we have to show that. Okay, so this the resultant matrix of B transpose AB, that is symmetric if A is symmetric. Okay, so think about it. If A is symmetric, A transpose will be A, right?
Yeah.
If A is symmetric, A transpose will be A. So if A is symmetric, at the place of this transpose, the middle one, we can substitute just A, matrix A. Okay, and the left one, right one, we will copy paste as it is. If A is symmetric, okay, if A is symmetric. So can we see we ended up getting the same matrix? We started with the transpose of this B transpose A, B transpose, and we ended up getting the same. Can you see, Kiran?
Yeah. Yeah.
So if A is symmetric, yeah, this matrix, okay, the circled one, that is symmetric. Can we say that?
Yes.
Okay, and if A is skew symmetric, in case if A is skew symmetric, that means A transpose must be equals to negative A, right?
Yes.
So here instead of A, if A is skew symmetric, here instead of just A, we will be substituting minus A. So this negative we can write in front, okay, completely in front. So yeah, we can see clearly that it became skew symmetric. So it is completely dependent on A. When A is symmetric, the circled matrix which is mentioned in the question is symmetric. If A is skew symmetric, this circled matrix which is given in the question, this is a skew symmetric. Got it?
Yeah.
Okay. Any confusion so far, Kiran?
No.
Okay.
No.
We can start with this. determinants. Okay, because matrix you have learned already. And yeah, let me know in the next class if anything you want to discuss from here with me. I'll be taking it. Just a moment, let me share the another screen. So basically determinants, okay, till now you have learned matrix. Okay, determinant is just a value we are associating with the matrix. Can you see the screen, Kiran?
Yes, I can see it.
Okay. So the way you can understand it in this manner, that suppose you are having a juicer, okay, in that juicer if you will put vegetables, okay, whatever vegetables you will drop over here, carrots or maybe pumpkin, whatever, you will be getting juice from here, right?
Yeah.
Similarly, determinant is like you are having a matrix. Suppose you are having a matrix A, that is 2 by 2 matrix, 2 here, 1, 3, 5, a 2 by 2 matrix you are having. Now you are dropping this matrix here, okay, in the determinant sign. This is how we will be taking the sign of determinants. Okay, same, each and every element, everything will remain same, and it will give you a output, a value it will give you, a value. Okay, the value will be, let me write the number 7. How we got this 7, that's what we will be discussing over here. Okay, so it's like a juicer. Okay, we are dropping in the matrix, we are having matrix. Now the same matrix, okay, we are finding the determinants of that. Determinants means was this matrix will give you a number, a result, a final answer. The final answer will look like a just a number, a value. Okay, and here the value will be 7. Now you will be learning the process of finding the determinant. So matrix will be given. Suppose a matrix A is there, which is 3 by 3. When we are talking about determinant, we will always be taking the square matrix. So 1 by 1, 2 by 2, 3 by 3. Okay, maximum here 3 by 3 we will be discussing. However, you can also find 4 by 4. Okay, so if we are having a 3 by 3 matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can find a result from this matrix. Till now, you have just learned how to add, how to do the subtraction, how to multiply a number, a scalar multiplication, okay, how to multiply two matrix. But here we will be finding a proper a value, which will be from now onward, we are going to call it determinants. Okay, so let's see how we'll be finding determinants. Keep it in mind that determinants, when we are talking, we will be sticking with the square matrix. Okay, so let's see how we'll be finding the determinants. So suppose a 2 by 2 matrix we are having, and we have to find the determinant. Before proceeding with the finding part, the calculation of the determinants, one thing let me clear, that we will be representing determinant with this sign, determinant of A, or maybe we can write it as a det in bracket A, determinant of A, or maybe we will be representing with this small, this delta sign. In mathematics this is called delta. Okay, so we can also represent it with this delta sign. These all the symbols we will be using from now onward, okay, for representing our determinant. Getting it?
Yeah.
Okay, let's move. So suppose we are having a matrix A. Okay, A11, A12, A21, A22, a 2 by 2 matrix we are having, and we have to find the determinant of A. Okay, this is not mod, which will give you always a positive number. Okay, previously you must have learned absolute value, that if negative number is there, it will always give you a positive result. Do you know that?
Yes.
Okay, so this is not absolute value. Yeah, it may look like that, but this is determinant which is related with matrix. Okay, so when you will be having number inside that, okay, we will be taking it as a absolute value, modulus. But when we are talking about matrix and then this sign is there, that means we are talking about determinants. Okay, so let's find the determinant of A. The process of finding determinant of a 2 by 2 matrix is we have to do this crisscross. This A11 we will multiply with A22 at first. A11 we will multiply with A22 at first. And then we will do the subtraction. Okay, and we will multiply this two with each other. That means A12 we will multiply with A21. And whatever value we will be getting, that is the final answer. Okay, so if in case you are having a matrix like this, okay, this is A, this is B, this is C, this is D. Basically, we represent matrix by this bracket or maybe by rectangular bracket as well. So if we are having a matrix like this, for finding the determinant, we will be taking the multiplication of A with D and then B with C. Getting it?
Can I ask something?
Yeah.
Would it be wrong if I minus B, if I multiply B and C first, then minus it from A and D?
Yeah. Okay, we cannot multiply B and C at first. We will always be doing the multiplication of A with D first and then B with C. Always. In this manner only we will be doing the multiplication.
Okay.
Now, one concept have you learned, Kiran? Let me write it over here only. That if you are having suppose linear equation, suppose your linear equation is a1x plus b1y is equals to c1, and one more equation you are having a2x plus b2y is equals to c2, then there will be one and only one solution when a1 by a2 not equals to b1 by b2. Do you know that?
Yeah, I know.
Okay, you have learned. So it will give you unique solution. That is the case of getting one and only one solution when a1 by a2 not equals to b1 by b2. From here only you can see that we can also write it in the matrix form. Okay, we can write it like a1 b1 a2 b2. Okay, and then let me write it over here. Just a moment. Yeah. Now we can multiply x, y like this. And here we can write another matrix C1, C2. Please check it. Okay, whatever we have written, it is making sense. Why? Because if you will do matrix multiplication, the first row with the first column, you will end up getting the equations. Check it, that A1 with x, A1x, then B1 with y plus B1y. And first row, job is done. Okay, now we will be taking the second row, and that we will be multiplying with the same, the first column. A2 you will multiply with x, and then B2 you will multiply with y. Getting it, Kiran?
Yes.
Okay, so what are we doing? We are just doing matrix multiplication. What I am trying to show you, I am trying to show you the linear equation which you have learned already in the previous class can be written in the form of matrix like this, and can be compared with the C1, C2 constant on the other side. Now you already have learned that equality of matrix can be taken as this element over here is same as that element over here. So are you realizing that yeah, we ended up getting our equation, the same equation, right?
Yes.
Okay, so when we are having linear equation like this, we can also represent it in the form of matrix like this. And now I am telling you matrix is, okay, when you are finding a single value, a single number from the matrix, okay, that's we are calling as a determinant. There is a whole process of finding determinants which we have just started discussing. Okay, so let's get back to this unique solution case. Okay, so a1 by a2 not equals to b1 by b2, you know this is the case where we will be getting one and only one point of intersection, and that's the case of unique solution. Now if we will try little bit, okay, simplifying it, we can say a1 b2 not equals to a2 b1. Okay, this type of equations you have never ever solved, but this not equals to, for now just write it as it is. Okay, and let's do everything just the way we do in equation. Okay, the basic equation. So can we write it as a a1 b2 not equals to a2, I mean this one on this side, minus a2 b1 not equals to 0. Can you see?
Yeah.
Okay, and what is this a1 b2 a2 b1? Can you, are you realizing, Kiran, that just now I told you that we can also find the determinants. So if I am writing this in determinant form, a1 b1 a2 b2, and I told you that we will be doing the multiplication this way only, first a1 with b2, so a1 b2, and then subtraction sign has to be there, and then a2 with b1, so a2 b1. Can you see?
Yes.
Okay, this result we ended up getting from our matrix as well. Okay, so basically it is showing that from the matrix we can get a unique number, a unique solution, which you have learned previously as well. Okay,
Yeah.
so you just need to get the little bit of idea that from a matrix we can find a value, a unique value, a unique solution, a unique number, one and only one solution. Getting it?
Yes.
Okay, now let's get back to the process of finding the determinants. We'll be doing few more example which will give you clarity for first 2 by 2 matrix. Then we will be starting with 3 by 3. Again, I am reminding, when we are finding determinant, we will stick with square matrix. So next one, evaluate this determinant. Okay, this is determinant sign. We have to evaluate the value. First, we will be multiplying this 2 with 2. Okay, that means 4. Minus, then we will be doing the multiplication of 4 with minus 1. So 4 with minus 1 will be minus 4, right, Kiran?
Yes.
So we are going to get 4 plus 4, that is 8. Okay, if it will be given the question like this, A is 2, 4, negative 1, 2, find determinant of A, you will be doing the same thing, whatever we have done now. Got it?
Okay.
Let's do
Yeah.
next one. Again, 2 by 2 matrix we are having. We will be doing the multiplication of this 2 at first. What are we going to get, Kiran?
X square.
Then minus. Then this 2 multiplied together. Let's write it. X plus 1 multiplied with x minus 1. Is there any formula which will help us doing the multiplication?
Formula.
Yeah. Does it look a plus b, a minus b?
All right. So yeah.
Yeah. So what is the formula?
A square minus B square, right?
A square minus b square. Perfect. So we'll be taking it a square minus b square. Why I'm not opening this curly bracket? Because carefully we need to open it. Okay. So now we'll be having x square minus x square. 1 square is just 1. So plus 1. Right?
Yeah.
We are going to get just 1. A unique value, a unique solution. Next. Here we are having again same 2 by 2. Okay. Matrix, that's determinants we are finding. Please tell me the value, Kiran.
So minus 23. I
Minus.
think.
No, right?
Right. Sorry, yeah.
It will be 18, right?
18. Yeah.
Yeah. Now the second one, as trigonometry is not much, okay, there, you can do this one. Let's do it. Please do it and tell me the final answer.
Okay. Uh,
Yeah.
I don't know if it's correct, but x cube plus 2x squared plus 2.
Plus 2.
Yeah,
Yeah, let's,
I'm not sure.
it's okay. Okay, let's check it over here. So if we will be doing the multiplication of this two, we are going to get x plus 1 multiplied with x square minus x plus 1. This two multiplied together will be again x square minus 1 square. Okay, a square minus b square formula directly we can apply. So this will give us here also the factorization is possible. Let me check. No. Okay. So actually we are going to get, you have done the multiplication of everything, Kiran?
Yeah.
Okay. If we will do the multiplication of this x with x square, we'll be getting x cube. This x with negative x will be getting minus x square plus x. And this will be x square. This will be minus x. This will be plus 1. Minus x square plus 1. So x square gone. Here x is there. Here also x is there. It's gone. Now 1, 1, 2. Yeah. X cube is there. I can see 1 minus x square. Nothing else. Right? Right, Kiran?
Yeah.
Okay. So yeah. Okay. Just the middle one. Okay. 2x square. It will be negative x square. Fine. Let's do this one. Today we will be sticking with 2 by 2 matrix because I need enough time to explain 3 by 3 along with the examples as well. So today we will be sticking with 2 by 2 matrix. Okay, and that's determinant we'll be finding. So if A is given over here, find the determinant of this matrix. We are having A square minus 2A. Okay, this will give you a resultant, okay, which will be a matrix, right?
Yeah.
And that's determinant we have to find. Okay, so first we will focus on finding a square minus twice a, the way you have learned in the previous chapter. Okay, that is matrix, that if we have to do the multiplication of a with a, that is a square. So 1 3 2 1, same we will be doing the multiplication 1 3 2 1, and we will be doing the multiplication row to column. Can you tell me, Kiran, what will be the final answer? A square we are finding for now, suppose, not 2, just a square.
1 second. I'll do it.
Yeah, please do it.
is the matrix 7, 6, 4, 7,
4.
7.
Yeah, perfect. It is. Okay. Now we will be taking as it is because we are supposed to find first the matrix A square minus 2A. Okay. So this is what we are having in hand. 2A, we can take this minus 2. Okay. In the bracket added with, we can write like this as well. So negative 2, then minus 6, then minus 4, then minus 2. Right?
Yeah.
Then we can add them. So 7 minus 2, 5. 6 minus 6, 0. 4 minus 4, 0. 7 minus 2, 5. So this is what we are having in hand. And now we have to find, this is the resultant matrix. Okay, and what is
Yes.
the question? Find the determinant of this matrix. Okay, whatever will be getting the resultant from here, that's determinant we have to find. So now the resultant is this one. That's determinant will be this 5005 like this. We will be doing the multiplication of 5 with 5 first. That is 25. And then 0 with 0 minus 0. So the final answer is 25. Right, Kiran?
Yeah.
Okay, let's do few more questions. So if we are having this type of case, here also we have to find x value. But the way you were, okay, we were doing the comparison and equality of matrix, that concept we were using in the matrix, that concept we cannot use over here. Okay, so by using the concept of determinant, we have to say what is the value of x. If matrix over here and the matrix over here will be given same, then okay, what we will take? We will take 2 and 2x will be same, right? And x value will be 1, right? Right? Right, Kiran? Are you there?
My mic was stuck.
Okay. Are you understanding this part?
Yeah.
But this concept is from, okay, this question will be from then matrix. If in determinants chapter, by using the concept of determinants we have to find the x value, then we will be using the concept of determinant. Like this 2 multiplied will be 2 and this 2 multiplied will be 20. So this is the determinant from this one is equals to the determinant from the other one will be 2x square minus 6 4 times 24, right? That
Yeah.
minus 18 here, twice x square minus 24. Let's keep it on in one side. So 2x square minus, okay, here we are having just 24, right? Yeah, so no need to keep it in one side. Directly we can take the numbers on the other side. So 24 minus 18, that is 6, right? 2x square, right?
Yeah. Yes.
Now we are getting from here that 2x square is equals to 6, right? X square is equals to 6 by 2, right? That means 2 3 times 6. X value we are getting plus minus root 3. Are you getting it, Kiran?
Yes.
So if this matrix, that matrix are equal, that is given, then that is another concept, okay? But if determinants are shown that this determinant and that determinants are same, then we'll be doing it this way. Got it?
Yeah.
Similarly, the next question, we need to solve it by using the concept of determinant. If this and this are equal, let's find the value quickly. So we'll be taking this 2 multiplied together will be x square and this 2 multiplied together will be minus 36. This 2 multiplied together will be 36 and this 2 multiplied together will be 18 2 times 36, right?
Yes.
So we are getting 0 over here. X square minus 36 is 0. X square is 36. X is
6.
plus 6 or minus
Plus
6?
minus 6.
Plus
Plus
1.
minus 6.
Yeah. Okay, this way we'll be solving. Now, if a matrix A is given to us, that is 1, 2, 4, 2. Okay, and we have to show this one. Okay, that if we will be taking 2A, Okay, over here, if we will be finding 2 times of matrix A, that is the scalar multiplication in this matrix, that will be 2, 4, 8, okay, and 4. This is 2A, and that's determinant if we have to find. So 2, 4, 8, 4, determinant will be 4, 2 times 8 minus 32, right, Kiran?
Yes. Yeah.
That means 32 minus 8 will be 2 from here, 6 from there, 24 minus 24, right?
Yes.
Okay, you can see clearly determinant can be negative, determinant can be positive, okay, determinant can be 0 as well. Okay, you will be getting such determinants as well. Now the other side we will be checking, is it same? So the other side says that 4 times the determinants of A. What is determinant of A? 1, 2, 4, 2. Okay, determinant will be 2, and 4 into 2 will be 8. That means minus 6, and minus 6 into 4, that means minus 24, right?
Yes.
And we can see, yeah, it is same, right, Kiran?
Yeah.
Okay, one concept I want to give over here. So in scalar multiplication, whenever we used to have a number, okay, 2, and you are doing the multiplication in matrix A, okay, you are having a matrix A and you are doing the scalar multiplication, you will be multiplying it with each and every element, right?
Yeah.
Okay, so basically from here, just a moment. Are you realizing that we did the scalar multiplication of 2 with A, and that's determinant is same as this 4. 4 means 2 is square, we can write it. Okay, and then matrix,
Yeah.
I mean, sorry, the determinant A. So if we are having 2, okay, the determinant of 2A, that can be taken as 2 is square. From where this square came? The order of the matrix, order. Okay, the order will come in the power. We will be doing so many examples like this, and you will realize always it is true. Okay, so if you will multiply, like suppose 3A you are having, always you will find the result of this determinant will be same as 3 to the power 2, the order of the matrix, and then determinant, always it will follow. What I'm trying to show, Kiran, that if you have to find the determinant of suppose 7A, that result and the result, that is 7 is square, and just the determinant of A, that will be same. From where this square is coming? The order, or the order 2 by 2 means, now if even if we are saying this is a matrix of order 2, okay, matrix of order 2, that is, whoever will listen this one, no, they will understand. 2 order 2 means 2 by 2. Getting it?
Yeah.
Okay, from now onward, when we will say order 3, a determinant, a matrix of order 3. So whoever will hear this one, they will understand. 3, order 3 means 3 by 3. Order 2 means 2 by 2. So that order is going in the power. Getting it?
Yes.
Getting it? This rule, this is a property, okay, which we will be verifying with so many examples. I can show you one more example. Okay, suppose 3, we are finding 3. Okay, we are finding the determinant of 3A. Let's find it quickly. What will be 3A? Okay, in determinant form I am writing. This element will be 3, this will be 6, this will be 12, and this will be 6. Right, Kiran?
Yeah.
Okay, if we will find the determinant, it will be 6 3 times 18, and 12 5 times 60, 12 6 times 72, minus 72. 72 minus 18, 4, and 6 minus 1, 5. Negative 54. Right, Kiran?
Yeah.
And I am telling you that there is a property